All right, so talking about histograms just a little bit more. As I mentioned before, this usually shows like a normal distribution, and we are used to seeing some kind of like average value in the center. Also, we have to know that this is the number of observations for some type of bin size, right? So we have a bin size here, and the more observations that occur in that bin, the higher that column becomes, right? So that's dealing with histograms. Line chart, typical line charts show forecasts, trends, whatnot. A very common thing is that we'll have dollars and profits, and then this at the bottom would be time. Okay. A scatter plot, typically scatter plots have two values. So we call it x1 and x2. Like when we were looking at the tire data, we were showing that we had tread wear and then miles, for example, and those were plotted across those two values and looks at the relationships. A very common thing might be height and weight. So sometimes people will put height on the vertical axis and weight on the horizontal axis, and then typically what would happen is you would see a trend. The taller people are, the more they weigh, and that would make sense. If you were to add a third dimension, like if you did height and weight, but then also you put their age, and the bigger the circle might be their age. Or another might be just the number of people that were measured. So let's say that you were going to go ahead and do the height and weight of the one of the girls' basketball teams, and you can see that if this is height on the vertical axis, you have a good majority of girls that are in this category that are very lightweight but are very tall. And then you do have some other girls that might be average in weight and average in height, and they'll have different positions. And then you have a scattering of different heights and weight across that athletic team. And this might give you some other indicators. So this is one way of using 3 dimensions instead of 2 in your scatter plot. All right, so in Excel, we've seen the Sparkline, and typically it gives us a miniature data visualization inside a cell. Keep in mind this one at the top, that is one Sparkline. And another way to represent it might be using a column chart, which is down here below. But these are not intended to be related. These are just examples of Sparklines. Stack bars. We've seen this especially with categories. Like this bottom could be the percentage of females, top could be percentage of males, and this could be over time. This could be Q1, Q2, Q3, Q4. And you can see that there's a reduction of males, let's say whatever we're measuring. And then a bubble chart. I had this note here at the bottom. It said, this is not recommended. And what this actually shows is that it's a count of the number of occurrences something might happen. So a lot of times people might use this in replacement of word bubbles. So like, for example, if you're going to go look at tweets that are related to any kind of news story, this circle here in the middle might be the most frequent word that would be in that tweet. And the next one might be the second most frequent, and then the third most frequent. The downside about this is that I was able to identify the first most, second most, and third most, but which one is the fourth most? I have some here, here, and here, and it's really hard to discern this. Bubble charts tend to make good pictures, but it's hard to really evaluate them to be able to make good decisions. So if bubble charts might be good for graphics, but for decision making, perhaps not so much. The same thing with concentric circles. Now, the question is that the idea is that this amount of run or this arc size on a circle is worth a certain amount. And here is another arc. Now, we can easily see that this arc has a difference of a certain amount, all right, to be able to determine that they're different. However, We also have some other variations, such as the thickness of these arcs. Does that mean something? Also, the distance from center. Does that mean something? This idea about arcs having some differences can also be confusing, right? And so a donut chart is the same thing. Again, we're using arcs. It's just another variation of a pie chart, except you don't have the concentric circles. And again, this is typically not recommended. Remember, I said in one of the earlier videos, there are times when sometimes this might make sense. If I was comparing two numbers, like this is the number of people that said yes, this is the number of people that said no, that could be usable in that case. So these are always rules, but they have some basic exceptions. The same thing with a pie chart. It's typically not recommended. Okay, right? It works when you want to measure yes versus no, male versus female, cold versus hot, some binary items. But what happens is that people tend to find difficulty in being able to interpret slices, and which slice is bigger, which is smaller. Visually, it doesn't give you the same amount of information that you might be able to get from, let's say, a column chart that's sorted from greatest to smallest. And word clouds is kind of like the bubble charts, and except now we're using text, so our eyes have to interpret the relative size of text to be able to get a sense about what is actually standing out. The advantage of word clouds is obviously the bigger the word, you get the sense that was the most important word in a document or a corpus of text, but it's not always very intuitive. All right, so I'm going to stop right here, and then we'll overview some effective design techniques in the next video.